Good morning. We will now be discussing box plots and histogram, specifically on using different technology in this particular case Desmos and TI-84 calculator to represent data using the real number line. We'll be attending to position and communicating our data and presenting our data using either box plot and histogram. So a box plot looks like this in here. It has a box and two whiskers in there. The leftmost um, value in there is the minimum value, and the rightmost whisker here is the maximum or the highest value. Now, to get the range, that will simply be the difference between the maximum and the minimum values. To get the values inside the box, we have the Q1, what we call the first quartile or the lower quartile. We also have Q3, what we call the third quartile or also called the upper quartile. And we have the middle quartile, which what we call the median. We also call it the second quartile or Q2. In terms of a histogram, it always has its x value and the frequency is along the y-axis in there. It will have the highest peak in here, which usually what we call the mode, because it's the value or the x value with the highest frequency, but it does not necessarily mean that the mean or the average, the median, the middle term, and the mode are all on the same or all having the same value. My first question in here now is, what do you think will be the shape of a box plot or a histogram in such a way that the mode, the median, and the mean or what we call the arithmetic average will be the same? Let us now go to our first problem in here on how to get the box and whisker plot of this data. Yvonne and her family went on a 10-day fishing trip. The data set below shows the number of fish they caught each day. So those are these numbers in here: 14, 4, 8, 16, 7, 12, 10, 11, 10, and 9. Which box and whisker plot represents the number of fish Yvonne and her family caught on their 10-day fishing trip? So once again here, we're interested to know what the box and whisker plot looks like in terms of representing this data. And these numbers in here are the number of fishes caught per day. So that'll be from the first day up to the 10th day. This time, let us use our Desmos first in representing this data using a box and whisker plot. I am now using my Desmos app in here to analyze this data or represent this data using our box and whisker plot. The first thing that I'll need to do is to create an array of values in here. Let's choose a certain letter L to represent this in here, and then make an equal sign. Then after that, I'm going to create a box in here like such. So I'm going to create a box in here like such. And I'll put inside the box the following values. I have 14 and then 4. As you see, I'm having these numbers separated by a comma. I have now plugged in all of the 10 values in here. On a typical manual computing of for the box and whisker plot, we typically need to arrange these values first from lowest to highest value, or what we call the ascending order. But in our Desmos case, or even in our TI-84 case, there's no need to arrange them in any order. So you can just randomly put in all of those numbers without any order. After this, I'm going to create another expression, and then on this expression I'm gonna click on the keyboard pad in there, or keypad, the icon in there, and then under functions I'm going to go to my dist, or what we call the distribution. And then after this, since I'm interested with a box plot, I'm going to click on a box plot in here. It would ask me to enter a data set. In this case, since I used L on the data set, then I'll put L inside in there for my data set. So as you can see in here, I already have my box plot, so I'll just need to clearly see it in here by moving it up a bit so I can clearly see it in here. As you may see, my box plot in here is the same color as the rest, which is black. But if I click on the box plot in here, then I can actually change the color into something else that I want, for example, a red one. And then after that, I can see the values in here for the following. For the minimum, Q1, Q2, Q3, and the maximum. Let's check it out. So again, analyzing this particular box plot in here, I could see that I have 4 as my minimum. I have in here as my lower quartile, or my first quartile. I have 10 in here as my median, or the second quartile. I have 12 in here as my upper quartile, or what we call the Q3. And I have my 16 in here as my maximum value. So there we go. We had the following values: 4, 8, 10, 12, and 16 for this box plot. So with that being said, we can see it as follows on letter C, where the minimum is 4, the Q1 is 8, the median is 10, the third quartile, or Q3, is 12, and the maximum is in fact 16. So there we go. The answer for number 1 is letter C. So an additional question for you guys in here is, since the range is the difference between the maximum and minimum values, what do you think will be the range of this data set? This time we'll be using our second question. In this case, we're going to use our TI-84 calculator in order to get the box plot for this case. So it says the table below shows the percentages of high school students who took a college entrance exam in 1997 for 11 states. One of these states' percentages is at the third quartile. So let's now use our TI-84 calculator for this particular case. So on using our TI-84 calculator, it's best to reset everything first, because we're going to use later the statistics tool of this calculator. And that will be second plus 712 to clear the memory for this. Now, in order to do that, we'll go to Stat, we'll go to Edit, click number 1, and under L1, we're going to put in all the data in there. So it says in here, we got the following in our data: 45, 46, 48. So I'm going to put 45 and then press enter. 46, press enter, and so on. But please do press enter for every number that you put in here. After putting in all of the 7 values in here, we don't really actually need to arrange everything either in ascending or descending order. Just put them all of the values in there randomly, then that will be fine. Now, in order to get the box plot for this, what we're gonna do is to use our stat plot function for our calculator. And as we may see, the stat plot is a blue function above y equals. So to get that one, I'm gonna press second and the y equals. Now I'm going to create a plot one by pressing enter on it, turn it on, go down to the type. I'm gonna choose the type of a box plot in here and then press enter on that one. It's gonna tell me that my X list is an L1 and the frequency is 1 and the color is blue. You can change the color if you want to. In this case, you can make it red if you want to. Now after this, what we're going to do now is to click on zoom and click on zoom stat. As we may see in here, the zoom stat is number 9. So I'm simply going to click 9 and I'm going to see now my box plot corresponding to our data set. Now, in order to see all of the values in here, I'm going to click on the trace and it's giving me the median right away. So if I have to go, which is 64, by the way, the median is 64. But if I'm actually interested with, according to our problem, I'm interested with the third quartile, then what I'm going to do is to press right in here. And the Q3 that I got is a 72. So again, the answer in here is 72. But which of among those states has that particular value? Then that will be Pennsylvania. By the way, it's not only Q3 and median that we can get in there. If I press right once more, then I'll get the maximum value at 80. If I go to Q1, it's 46. That's the lower quartile. And the minimum value is 45. By the way, as an additional question for our second problem, what do you think is the state that has the median or the middle value of all of these college entrance exam percentages? Our here is on creating this time a histogram, and we'll be using our Desmos for this case. So it says the table shows the number of children ages 3 to 12 who attended a movie. Which histogram best describes or represents the information in this table? So again, let's use our Desmos for this case. Seeing in here, the age is actually the age values and the number of children actually represents the frequency or how many times that age actually was registered in there. So in doing my Desmos in here, let me put this as big letter C for number of children and then equal sign. And then once again, I'll use this box or a square array in here. And then after that, no, it's not actually a square array, but just a bracket in there, and then our square bracket in there. So I'll put in here, there's just one 3, and then for the 4, there's just one 4 as well. So again, I'm separating all the values using commas. For 5s, there are 3 of those 5, so I'll put 5 in here 3 times, and I'll do the same with the rest. So it says in here the 6 age is 0, so I'm not gonna put any 6 in there, but for 7 there will be 4 of them. 1, 2, 3, 4. I'm going to continue with this method as soon as I reach the age 12. Continuing with all of the values, I should be having 20 elements here. If I add all the frequencies in here, then that will be a 20. That's 1 plus 1 plus 3 plus 4 plus 3 plus 3 plus 2 and 3. So as you may see in here, there are 12 3 of those 12s, 2 of those 11s, 3 of those 10s, 3 of those 9s, none of those 8s, and so on. After this, I'm going to create now my histogram for this one by pressing plus in here or add item. I'm going to create an expression in here, but under the expression, I'm going to click on my keyboard in there, and then under the functions, under the distributions, I'm going to create once again a histogram for this one. It says in here what will be my data set and what will be my bin width. So for my data set, that will be my letter C or the big C. And it actually gives me now our data set for this case, which looks like as follows in here. So I can drag this down so I can clearly see it. Now, there's a count or by bar heights, and there's a bin alignment in here as well. So the bin alignment in here, I can set it up to left or center if I want to in this case. Now what I'm going to do right now is to play with the bin width in there. So after that value C, I'm going to put a comma, and to put a bin width, a while ago is just 1. So let's make it a 2 in here, which means that in fact it joins two values like 3 and 4, the 5 and 6, the 7 and 8, the 9 and 10, and the 11 and 12. And then after this, I can make it to the left or to the center if I want to. So if I will make it to the left in here, let's try to see that one. And I can make it to the center as well and try to see this one in here. Now, having said that, then this is actually, in fact, this first bar of this histogram is in fact from 3 to 4. This is from 3 to 4. The other one will be from 5 to 6. The other one will be from 7 to 8. From 9 will be the other bar. And the last one will be the bar from 11 to 12. And with that being said, then we can already have our answer in there. Letter B in this case. With that being said, then we can say that the modal class in here will be the class of age 9 to 10 because it has the most number of moviegoers, which are 6. But as you may see, if you get all of the values, then this modal class is not equal to the arithmetic average, or what we call the mean. Our question this time will be, what do you think will be the shape of a histogram in such a way that the modal class and the mean will be the same? I'm confident now that on your own you can solve for the lower quartile of this particular problem in here. Aaron measured the heights of his plants. The heights in inches are shown below. What is the value of the lower quartile, or what we also call the Q1 or the first quartile? Again, let me know if you have questions regarding how to use our calculator and Desmos for a box plot and histogram. And once again, tell me QUAN-do. You can do math.